Now we will see the control charts numerical. So before going to on numericals, what mean by the control charts? So control chart is a graphically representation of collect the information. The information may be patterned to measure quality characteristic like length, diameter, thickness, etc. Control chart is a device to specify the state of statistical control, or it is a procedure to attain or achieve statistical control, or it is a tool to judge whether the state of statistical control is attained or achieved or not. So commonly charts which are used is the first X chart. So this X chart, the average of measurement is in sample, since it is called as the X chart. If the range of measurement is a sample, then it is R chart. The percentage of defective in a sample, so it is a P chart, and number of defects in sample is known as C charts. So number of defects are there, so it is C chart. Percentage of defect, then it is P chart. Average of measurement R chart, and range of measurement it is R chart and X chart. So what are the purpose of these control charts? So first is to determine whether the given process can meet the existing specification or not. Second, to secure the information to be used, established or changing production process. Third, to ensure the optimum product quality level. Fourth, to find out the lots which is need 100% inspection instead of sample inspection to save the cost of wastage and goodwill of the consumer towards company. Fifth, the quality characteristics can be measured as well as expressed in a number. Then to give the feedback which can be used for planning and control purpose in a future. So now we will see the first numerical. What are the such numerical asked? So first, find out the mean, mode and median of a following data, that is 2, 3, 4, 5, 2, 3. These are the numbers. So first we find out the mean. So calculate the mean, that is the X bar. We have these all 2 to up to 5. So calculate that X1, X2, X3, that nothing but the 2, 3, 4, 5 given example. So addition of that all these number and count that is total at 10. So n is equal to 10. So mean is equal to addition of total given numbers divided by the total numbers. Yeah, so it's we get answer 3.7. Then second, mode. What is in my mode? In a given example there are different values are there, 2, 3, 4, 5. So 2 comes occur 2 times, 3 comes in 2 times, 4 comes in 3 times, and 5 comes in 3 times. So as a 4 and 5 occurring most of times, so both are the mode. Yeah, it is, so it is called as bi mode. Now median. So arrange the given example in ascending order, that is 2, 3, 4, 5 at a given count, and then there is a formula for the median, that is n upon 2 and n plus 1. So n by 2 is 5, so term is 4, that known as the, because n by 2 is the n by 2 is equal to 5 plus 1, that is 6. So 6 term count 2, 2, 3, 3, 4. So answer is 4. Okay, yeah. So we will go the next problem. So these are the chart which is given X and R, and given is given, that is the A2 is equal to 0.577, D3 is equal to 0, D4 is equal to 2.114. Draw the appropriate control chart and put your conclusion. Now first we calculate that X double bar. That the formula of X double bar is summation of X bar upon n. So X bar and summation means calculate the all X bar up to 1 to up to 10 divided by the n, that is 10. Then calculate the R bar. So summation of R divided by n. So calculate total 1 to 10 total R and divided by 10. So answer come of X double bar is 0.00195 and R bar is 0.018. Now then next step we calculate the control limits, that is the two limits, upper limit and lower limit. So upper limit for X bar is equal to X double bar plus A2 into R bar. This is the formula. So X double bar now we already calculate by using formula summation X dash upon n. and r bar also we calculate, that is summation r upon n, and a2 is given in example, that is the 0.577. so after putting the value we get the 2.012. then in lower limit just difference is only in sign, that in upper limit there is a plus, while in lower limit it is minus, that is x double dash minus a2 dot r dash. so we know the all values, so after putting we get the answer 1.99. Similarly, we calculate the control limits for R chart. So upper control limit for R is D4 into R bar, and lower control limit for R is equal to D3 into R bar. So R bar is given, D4 and D3 is given in example. So we get the value, that is upper control limit is 0.038 and lower control limit is 0. Now conclusion. So we can draw now this in chart, and suppose the all points of a given examples x dash and R, if it is false between the upper limit and lower limit, then system are going to be controlled, and if it is false outside the upper limit and control limit, then system are going to be uncontrolled. Or let's see. So here is a diagram we draw. We get the upper control limit is 2.102 and x double dash we calculate by using formula, that is 2.00195, and lower control limit also we calculate. After putting these all points, we will see we will draw some bar. Second, for R chart also we calculate the similarly UCL, that is upper control limit of R and lower control limit of R and R dash, and plotting the all parts. Now the next example, in this example is similar to the previous, just only difference is they said first specific calculation and control charts, and okay. So here is the example. So in this example what happened, there is a first we calculate the x double dash by adding a summation of x dash upon number of sample, that is 10. Then we will calculate the r, that is summation of r upon n. Then we calculate the control charts limits for the x dash and r dash. So control limits for x dash are x double dash plus a2 into r dash. So we know the all values. Similarly LCL, that is lower control limit for x dash, so only sign difference was there. Then we will go for the control limits for R chart. For UCL, upper control limit for R is equal to D4 into R dash, and lower control limit D3 into R dash, all value we know. Then we calculate the process capability. For a process, here is the one more point, they said to calculate the process capability. So for process capability we calculate the x max and x minimum. So x max, that is 59, is the given process capability, plus minus 3.5 are given tolerance. So for x max we calculate the 59 plus 3.5, and x minimum 59 minus 3.5. So specific tolerance is x max minus x min, so it comes with 0.7. For the neutral tolerance, 6 sigma dash is equal to 6 into r dash upon d2, that is sigma dash is equal to r dash upon d2. d2 is given, r dash we also given. So we can calculate the x dash, and here is the x dash, and process capability can be come out. Then we will see the next, that is the P chart. For P chart, the following are the result of 20 lots. Each lot contains 750 objects. Number of defective objects in each lots are follows. So they are given some examples, and analyze the based on appropriate control charts, calculate control limits, and state whether the process is controlled or not. Okay, so they are given total n is equal to 750, and that is the each lot contains 750 objects, so it's n. Number of lots is 20, so 48 to 57. So we will calculate first the defective as 48, so we calculate, that is the fraction defective, number of defective 48 divided by 750, that is lot size or number of article inspected. So similarly we can calculate for second, it's 83 divided by 750, for third it's 70 by 750, for fourth it's 85 by 750, such like we calculate the all lots number, that is 1 to 20, and we get the fraction defectives. Then we calculate the central line of P chart. What is there are three lines, that is first is the central line, then upper control which is above the central line, and below it is lower control. So for P chart we calculate the central line, so it is formula is total number of defective to the total number of workpiece inspected. So total number of defective means total number of defective calculated, so this summation is 1139. to the total number of workpiece are 20 into 750 are the object. So 20 is a lot number, 750 are the object. So 750 into 20. So answer come like 0.076. Now we calculate the upper control limit, lower control limit. Upper control limit for the P formula is P dash plus 3 into square root of P dash into 1 minus P dash upon N. So P dash we calculate, that is the center line, 3 is a constant and N is equal to 750. Yeah. So similarly we calculate the lower control limit. The only difference is sign, that is P dash minus 3 into square root of P dash into 1 minus P dash upon N. So answer come upper control limit is 0.105 and lower control limit is 0.05. Now we draw this chart, that is upper control limit is 0.105, the lower control limit is 0.05 and center line P dash is 0.075, and we can all the points we are drawn on this chart, and we will see if it is false upper control above the upper control line and below the lower control line, that system are not control procedure. Okay, thank you.